Chapter 11 is on the counting principle and probability. Starting with the first section, 11.1, the fundamental counting principle. The fundamental counting principle in math says if you can choose one item from a group of m items and a second item from a group of n items, then the total number of two item choices is m times n. So in summary, all this fancy principle says to do is when you're counting, when you see the phrase how many in a word problem, at the very least you're going to be multiplying. So you're going to multiply all the different options, all the different choices that you have. So in this chapter, especially for the first few sections, when in doubt, you're going to be multiplying. So keeping that in mind, example 1 says a restaurant offers 10 appetizers and 15 main courses. In how many ways can you order a 2-course meal? So the first 3 sections deal with counting in this chapter. So we're not going to do probability until we get to section 11.4. And we know it's a counting question because as I've circled, you do see that phrase, how many? So we said when in doubt, the game plan with these counting questions is to multiply. You multiply the number of choices, the number of options you have. So let's see, for appetizers, you have 10 choices to choose from, times main courses, you have 15 to choose from. And sometimes you might see some extra information you do not need. So yes, it is a 2-course meal, but who cares? That does not involve how many choices, how many options we have. So I've X'd out. You can ignore the 2-course part. In fact, I'll just scribble that out. So 10 appetizers times 15 main courses to choose from gives us a final answer of 150. So there are 150 different ways that you could order that meal. So many different scenarios they could give you in the My Math Lab homework. So now example 2, we switch up from food to clothing. It says you own 5 pairs of jeans, 20 t-shirts, and 12 pairs of sneakers. And then again we see the phrase, how many? How many choices for wardrobe do you have with these options? So again, the theme is multiply all the total options. So we have 5 pairs of jeans times 20 t-shirts times 12 pairs of sneakers. And by the way, you will definitely want a graphing calculator for this entire chapter. Later on, we're going to be using some of the features of the graphing calculator. So 5 times 20 times 12 gives us 1,200. So 1,200 different wardrobes you could create once you multiply all the options together. 1,200, final answer. Example 3 says car manufacturers are experimenting with lightweight cars designed for one person and considered ideal for city driving. Suppose you could order such a car with a choice of 9 possible colors, with or without air conditioning, electric or gas powered, and with or without an onboard computer. In how many, so it's still counting, I see the phrase how many, in how many ways can this car be ordered with regard to these options? So we've got a lot more choices to choose from here. Let me erase a little bit so that I don't have too much writing going on this slide because I'm about to show a lot more work for this question. So whenever I'm going to multiply a lot or whenever it's a more complicated question, I like to draw underlines for whenever I'm multiplying in this chapter. So let's see. We know we're going to be multiplying because we're counting, good old counting principle again. And the first option we have is colors. So the first underline, I'm going to label it colors, times, and there were 9 total choices to choose from. Yes, you'll pick one of those 9 colors, but again, it's the total number of choices that you use in your actual calculations here. So 9 total colors to choose from, times the next decision they want you to make is about air conditioning. So I'm just going to label this AC, the next underline here. And technically there are 2 choices, either with or without air conditioning. They must not live in Florida because without air conditioning would not be a choice for Florida. So 2 total choices to choose from in regards to the air conditioning, times the next choice is about electric or gas powered. So I'm just going to label the next underline power. So there are 2 options, either electric or gas for there, times, and then the final decision is if you want this onboard computer. So I'm going to label the last underline computer. So you could either have with or without, so that's 2 total choices. And again, you don't have to draw underlines, but I'm just going to do that for whenever I'm multiplying in this chapter and it's a more complicated word problem like this. It just helps me to visualize the scenario a little bit better. So now we just simply multiply. You'll definitely want a calculator on hand, although this one's an easier one to do in our heads. Sometimes the numbers are not so nice in the MyMathLab homework, unfortunately. So we have 9 times 2 times 2 times 2, and after you punch that all in, you should be getting 72 as the final answer. So there are 72 different ways that you could create a car with those options. So for example 4, we're going to amp it up a little bit more, kick it up a notch. Any of the password or license plate questions, which say how many, are still going to be counting questions, but we just want to take our time when we figure out what numbers to multiply for these types of questions. So for example 4, I have a password used to gain access to a computer account is to consist of 2 lowercase letters followed by 4 digits. So 2 letters followed by 4 digits. Determine how many different passwords are possible if, and then I have an A, a B, and a C. And each part is just a little bit more challenging. So before we look at A, please keep in mind when we can choose from all the lowercase letters, A through Z, that means there are 26 total choices to choose from, because obviously 26 letters in the alphabet. So if they say just the lowercase letters, or even if they said in the homework just the uppercase letters, you have 26 letters to choose from. Now, I could so see MyMathLab throwing a trickier question at you. So what if MyMathLab says that you could use lowercase or uppercase letters? If that happens, you have 26 lowercase letters plus 26 uppercase letters. So in that case, you would have 52 total options to choose from. So my point here is that you have to really read these questions carefully. So for this particular example, it's only lowercase, so that's just 26 total options. Now, digits, they might say digits, they might say numbers. Keep in mind digits means 0 through 9. So you want to include 0 in your count. So that means there are always 10 total options if you can use any digit. So 0 plus 1 through 9 are 10 total numbers, or 10 total digits to choose from. So we're going to keep that in mind. I'm going to draw a little divider here as we look at A, B, and C. A says repetition of letters and digits is permitted. So when it says repetition is permitted, that means you are allowed to repeat the letters and digits. So for example, if I'm creating my password, if I want to use the letter A twice, I can. If I want to use the digit 3 all 4 times, that's fine too. So you're allowed to repeat is what that repetition is permitted means. So keeping that in mind, it says how many. It's a counting question, so we are going to multiply. I'm going to draw underlines again to kind of game plan this out and visualize it better. So we're going to have 2 lowercase letters. So I'm going to draw 2 underlines and label them each L for letter, followed by 4 digits in this password. So I'm going to draw 4 more underlines and label those 4 D for digit. Remember, we're always multiplying. That's that fundamental counting principle. So I'm going to put little time symbols in between my underlines. And then I'm going to go through each underline at a time. Please keep in mind, it's so easy to forget that even though we are picking 1 per slot of our password, it's always the total number of choices that we use in the calculations. So what do I mean by that? Well, if I look at the first spot, which is a letter, I have 26 total lowercase letters to choose from, A through Z. Yes, I'll end up picking 1 of those 26 to use as the first character of my password, but it's the total number of choices per spot that I use in the calculation. So I have 26 total choices for spot number 1. Each underline in my picture represents a spot, a character in this password. Now I move to the second letter spot. And if it helps, think of an example in your mind. So let's pretend that in the first spot I chose the letter A. Now in the second spot, I'm allowed to repeat letters. So I'm back up to A through Z to choose from again. So again, there are 26 total choices for spot number 2, A through Z to choose from again, because I could use A again if I wanted to. Now we go over to the digits. For the first digit, we said there are 10 total digits, 0 through 9 to choose from. Let's pretend I chose 0. Since I'm allowed to repeat, repetition is permitted. I can choose from all 10 for the second digit spot, 0 through 9, and 10 options for spot number 3 in the digit spot, and then 10 again. So using the total number of choices for each spot in my password, I'm going to end up with a large answer, that's for sure. But when you punch this into the calculator, we have 26 times 26 times 10 times 10 times 10 times 10. I encourage you to try this in your graphing calculator at home while you watch this video. You might even want to pause the video, try it, make sure you get the same answers I'm about to get. You can use your graphing calculator app on your phone even. But when I punch it in, I get 6,760,000. So since that, with my big old handwriting, I don't have enough room here, I'm going to erase and rewrite and move some stuff around so I have enough room to write this answer. So I said the answer for A is 6,760,000 different passwords you could create if you're allowed to repeat a letter and a digit. If you're allowed to repeat any digit and any letter. And I'll rewrite back up here that For lowercase letters, you have 26 total options. And for the digits, you have 10 total options. There we go. You do not have to type in the commas into the MyMathLab answer box. I like to insert commas just because it helps me to read the number out loud. So when I get a really big number on the calculator, I insert a comma going backwards from right to left after every 3 digits. That helps me to be able to read that number better. All right, so we're still on example 4, so we still have 2 letters followed by 4 digits, but B says repetition of letters and digits is not permitted. So this is going to be a little bit harder because now we're not allowed to repeat a letter or a digit. What does that mean? It means, like, let's say I pick A as the first letter of my password. I can never ever use A again. Same with digits. If I pick 0 to be in my password, I can only use it once. I cannot put multiple zeros in my password. So keeping that in mind, I'm still going to start this problem the same way as I did part A. I'm going to draw underlines. I'm going to be multiplying because it's still how many. And we still have 2 lowercase letters followed by 4 digits in this particular example. There we go. In fact, let me move this over actually. Let me draw this smaller because I'm not going to have any room with my big old handwriting here to write the final answer. Okay, trying this again. There we go. Letter times a second letter times a digit times the second digit times the third times the fourth. There we go. Okay, so starting with the first letter, we have 26 total letters in the alphabet to choose from, A through Z. Since we're not allowed to repeat, let's pretend I choose A for the first spot. Remember, each underline in my picture represents a spot in the password. It's a total of 6 characters in this password. So I'll pick one of these 26 letters. I pretended that I chose A. So when I move over to the second letter, since I'm not allowed to use A again, I'm down to B through Z to choose from. So I'm down to 25 choices. Yes, I'll just pick one of the 25, but I'm using the total choices in my calculations. I'm going to pretend I chose B as my second letter. Now for digits, I have 10 total digits to choose from, 0 through 9. Let's pretend I choose 0. Since I'm not allowed to repeat digits either, after I pick one of those 10, I'm down to 9 choices to choose from. Let's pretend I chose the number 9. Then I'm down to 1 through 8, so I'm down to 8 total options. Let's pretend I chose the number 8. Then I'm down to 1 through 7, so then I'm down to 7 options. So I just keep subtracting from the total number of options how many spots have been filled. So after there were 10 total digits minus, I'll choose one of those 10 to put in that first spot. Then I'm down to 9. 9 minus, I'll choose one more digit to go in that spot. I'm down to 8. Minus 1 of those 8, I'll choose to go in that spot. I'm down to 7. So I'm still going to get a large answer, but it won't be quite as large as A. When I multiply this out in the calculator, and when we do that, so we have 26 times 25 times 10 times 9 times 8 times 7. Check, you should be getting 3,276,000 different passwords you could create if you're not allowed to repeat a letter or a digit. And then finally, C is the hardest one. If it helps, you might want to think of an example and write it on your scratch paper just to kind of to visualize this a little bit better. But C is still going to be 2 letters followed by 4 digits. So I'm going to draw my underlines. But it says the first letter must be a vowel, meaning A, E, I, O, U. So let me label. First letter has to be a vowel. And the first digit cannot be a 0. So here's the first digit. Let me write no 0 on it. Right, no. I'm going to write the word 0 just because it's going to be too confusing because I'm going to have numbers above the underline in a second. So I don't want to write the number 0 and then I have another number above. That's going to look really weird and be confusing. So I wrote no 0 out in words. And repetition of letters and digits is not permitted. So on top of these 2 restrictions, we're not allowed to repeat any letters or digits. Okay, so looking at the first letter spot, we said the first letter of our password has to be a vowel. And even though I'm just going to pick one of the vowels, remember the trick here is that it's the total number of choices that I use in my calculation. So I have A, E, I, O, U to choose from. So I have 1, 2, 3, 4, 5 vowels to choose from. You'll pick one of the 5 to put in the first spot of your password. So again, I think it helps to think of an example with these harder questions. So I'm going to pretend I chose A, the vowel A. When I move over to the second letter spot, here's where it's so easy to make a mistake, is the spot after a restriction takes place. You don't have to use a vowel if you don't want to for the second spot, but keep in mind we're not allowed to repeat anything. So if I used the vowel A in my first spot, I can now choose from B through Z as my second letter. So, in other words, there were 26 total letters in the alphabet minus the one vowel that I chose to use in spot number 1. So that, in my example, B through Z means I'm down to 25. So again, there were 5 vowels to choose from in the first letter spot. You actually only picked one of the 5. That's the catch. I didn't use all 5. I picked one of those 5. So I just pretended that it was A that I chose in the first spot. When I move to the second spot, I'm not allowed to use A ever again for my password, so I'm down to B through Z, which is 25 letters remaining. So I'm going to pretend I chose B in the second spot. Now, as I look at the first digit, it can be anything as long as it's not 0. So I'm going to pretend, I'm going to just say that I use 9 is what I'm going to pretend. So if you can choose anything though besides 0, then you have 1 through 9, which is 9 total options to choose from. And if it helps, let's write out this example. So you could choose 1 through 9, just cannot use 0. So that's 9 choices to choose from in the first digit spot. So I'm looking for some room on my slide. I'm just going to try to squeeze it in on the end here of this question. I think it helps with a harder example to see a picture. So let's say then, so here are my digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So for the first digit, the restriction said we cannot choose 0. So if we cannot choose 0, that means I have 1 through 9 to choose from, which would be 9 total options. I'm going to pretend that I chose the number 9 to use in that first spot. Since I'm not allowed to repeat, I can't ever use 9 again. When I move to the second digit spot, I can use 0 now. The only restriction remaining is I'm not allowed to repeat whatever I used before. So now 0 is back up for grabs in the second digit spot, but if I've used the number 9, I'm down to 0 through 8. 0 through 8 means I have 9 total options to choose from. I'll pick one of those 9 numbers. Let's pretend I choose the number 0. So that's gone. Now I move to the third digit spot. I'm left with the digits 1 through 8, which means I have 8 total options to choose from. I'm going to pretend I choose the number 8 in that spot. So now for the final digit, I'm down to 1 through 7 in my little side example here, which means I have 7 total options to choose from. I'll pick one of those 7 and so on and so forth. So again, to summarize, the first digit could be anything as long as it's not 0. So that's 9 total options, 1 through 9 to choose from. You'll pick one of those 9 numbers for the first spot. Then you can use 0, you just can't use the one number you selected in the previous spot. So 10 digits minus the one you chose prior is 9. Then minus, you'll choose one of those 9 again. You're down to 8. Minus 1, you're down to 7. So if you can see through all my circles, the numbers we're going to multiply here are 5 times 25 times 9 times 9 times 8 times 7. And when you do that, you should be getting 567,000 as the final answer. 567,000. So that is section 11.1. The next video is going to be a mixture of sections 11.2 and 11.3, which are going to be more counting formulas. So you're still going to see the phrase how many, but we are going to need the graphing calculator, just as a heads up, for the next video.